Hello, good morning, everyone. Welcome to our February webinar. I hope that you are all well and that this lockdown is bearable. I think when Simon, Greg and I set these up a year ago, we sort of envisaged that they would go over March and April, and we would have 5 or 6 weeks before we'd be back out and be seeing you all again and conducting our business as we'd like to. But that's obviously not the case. We're here halfway through this current lockdown with another few weeks to go. But I hope that the information and the content we've provided has been useful. And we all look forward to seeing you again, hopefully in the summer, where we can do this face-to-face and not rely on the social media and the virtual forums that we have done. But in the meantime, we have a webinar for you today called BSEN40, to design or not to design. And this webinar is really just to try and simplify the process of structurally testing a column, taking the information you'll give us for the attachment you'd like to install and putting it through a design process that hopefully approves that attachment. If it doesn't approve the attachment, what it might do is recommend alternatives that might allow that attachment to pass with different configurations. So we'll go through this and hopefully, like I said, you'll find it interesting and informative. At the end, if you'd like to ask any questions, there'll be a facility just to type in a question at the bottom, and then we can get that back to you as soon as we can. So without further ado, let's start this webinar. So as we know, lighting columns are everywhere. They're there to aid the road user and the pedestrian. They're there for safety reasons. They're there to prevent crime, to prevent the fear of crime. And because there's so many of them, they're ideal candidates for additional infrastructure and equipment. But however, lighting columns in the modern day are designed specifically. They're designed to a standard, which means they're designed to take a bracket and a lantern, and any additional equipment that you'd like to add to that column needs to be approved. And it's likely that there isn't enough inherent strength in that column to take the additional load if it's not designed for. The reason there isn't any additional load in these columns is often down to financial constraints that we've seen over the last 20 years. Certainly in the early 2000s, PFI contracts were very popular, and column manufacturers who wanted to be competitive with their product and were tendering in some cases for 100,000, maybe 150,000 columns into a single standalone contract. They needed to get their product out of the factory really as efficiently as possible. So they designed out a lot of the inherent strength that may have been built in previous to that. So grade of steel was reduced, maybe wall thickness was reduced. The column was pretty much on the limit for its purpose, the purpose being to support a bracket and a lantern. So design strength has been reduced. There is no guarantee that additional attachments will be approved. And if they're not new columns, then older columns will need to be structurally tested to identify if there is capacity remaining. This is a fairly traditional street scene that we now see in modern life. Half a dozen columns, of which pretty much everyone is supporting an attachment. There's brackets there, there's CCTV cameras on here, there's spring-loaded banners. So I think it's an indication that we ask a lot of our infrastructure, far more than just lighting it. We're looking for it to host a lot of additional attachment and signage. So the reason we need to take in structural considerations is that when we're putting these attachments onto columns, they're often in areas of a high pedestrian count, of high road usage. The reason being, if we're putting a banner on a column, we want people to see the information on the banner. If we're putting a decoration or a basket, we want people to enjoy visually the attachment. If we're adding a camera to a column, it's because we want to see them. So naturally, we need to make structural considerations to the columns that we're using. That's not always easy because a lot of the time when we're using columns for certainly seasonal decorations, they can be in areas where the columns are ornate, they're heritage columns, they're embellished columns, they're columns that are difficult to structurally test. But it doesn't mean that they're not safe columns, because often the older the column, the longer it's been in situ, potentially defects have appeared. The column on the right-hand side is a classic example. This was one that was identified in Kent, county of Kent, and actually necessitated a whole county-wide program of excavating the root section, cleaning back the root, cleaning away the weld area and the lower plate, and then structurally testing with ultrasonic devices. It wasn't possible to test the column from above ground level, so it was a significant commitment to identify whether these columns had below ground defects. And only once, when the defects were either identified or not found, was then the column passed or approved. So like I said, the operator must demonstrate that any attachments made to a lighting column will not compromise its structural integrity. And we talked about the columns being very much on the limit. They can sometimes be approved to hold a 0.3 square meter sign, but that's not always the case. And certainly the case on the column on the right-hand side, which has 5 attachments on, it's clearly that column should have been designed to take that configuration. And if it hasn't, then the column will be overloaded. We're quite fortunate in the industry where we see safety alerts, and they enable us to identify problems, and we obviously act accordingly as an industry. When we see safety alerts for column failures, there's often a link with an attachment that's being supported by the column. This one came through a couple of years ago. It's a column that's 23 years old. It's a folded sheet steel column. It's coastal located, so it's obviously exposed to high winds, it's exposed to sea and salt air, but it also houses a CCTV attachment to it as well, and that was a contributing factor. You can clearly see on the right hand side there is corrosion at ground level, but the additional attachment has contributed to the column failing. The action on this incident briefing was that the immediate inspection and removal of all the redundant CCTV masts on that stretch of road. So the contractor responded to the safety alert. This one I find fascinating in many respects, because a lot of the safety alerts that are brought to our attention, the columns are defective. There are evidence of corrosion or damage to the column. This is a newly installed column, so it's within a year or so old. It's been installed into a new scheme. It's not been approved for a solar panel, but a solar panel of approximately 1 meter by 2 meters has been installed on a fixed bracket. So it's not a spring loading bracket, which would allow the panel to move and the wind to disperse around it. So that solar panel has taken the full force of the high wind event, and the wind event was obviously that aggressive that it snapped it at the shoulder. So you're looking at a 4 or 5 mil column that's newly manufactured, that can that will snap in half when it's applied a wind load that's that considerable. So I think if ever we needed evidence that attachments can be destructive, and if we ever needed evidence that we should be designing for attachments and approving them, then this clearly is probably the most crystal clear example that we have. This one is a floodlight configuration. It was put onto a 5 meter column, mild steel, tubular steel as well. You can see there is some ground level corrosion there, but it wasn't designed for the attachments, and the attachments again were a contributing factor on the column failing. So again, that necessitated testing the rest of the infrastructure, but not only testing it, it was then obviously getting the lantern information and the floodlight information and putting it through the calculation process. Like I said, in lots of cases when we see column failures, they're related to the attachments that are on the column. So again, there's more evidence really to support the fact that if you are looking to attach signage, if you are looking to attach decoration or basket or CCTV, then be careful and make sure the columns are approved, make sure they're in a condition that can withstand them. Sign lights on the left, the base compartment failure in the middle. You have some traffic signs on the right hand side. So again, just more evidence to show you that attachments are an issue. And just finishing off on this, we shared you this video. Amazingly, this video shows a column failing. It's falling between two rows of cars. If you haven't seen it before, it is pretty horrendous. But it's got a sign on, and it would be interesting to know whether that column had that a sign designed for, whether it was approved for when it was installed. So the process that we undertake if we are designing for an attachment is that we can complete a structural test on site. So it's important for us to determine if there are any defects in the column. Here we're testing the base compartment, we're testing the root section. We'll then reverse the field and we'll test the lower part of the shaft and the swage area. So we're looking for loss of section, we're looking for corrosion in those areas. It's not to say that a column can't be corroded in certain parts of the column and still pass the design. However, if you are proving columns that have corrosion, then you're only increasing the stresses onto the column. And whilst it may be approved, it might just have a short duration for that approval. So phase angle technique, structurally testing the column. In addition to the structural test, we need to take a series of measurements at the same time. We complete a data sheet, and in that data sheet, we're measuring the circumference of the shaft, of the base compartment. We need to record any existing attachments that are on the column and add those to the data sheet. And then we need to take a series of measurements from ground level so that the design consultant has the full specification of the column. In addition to the work we do on site, we need our clients to help us with the information with regards to the attachment. So you'll provide us with the height, width and depth of the attachment. You might have a drawing or a data sheet, and you might have some photographs. In addition, we'll need the weight and also information on the brackets that support it. You'll then tell us your desired mounting height, and we'll hopefully design to that. If we can't, then we'll hopefully pass it and recommend a specific height that you can actually attach the attachment to. So on the left, you have our data sheet we work with on site. On the right, you have the data sheet that we ask you to complete. So simply on the left-hand side, remember we've structurally tested the column, but now we're going to record the column material, we're going to record the column section, the column type, the bracket arrangement, we're going to record the column height. We need to measure the base thickness of the column, we need to measure the shaft thickness of the column, we need to know the cable entry hole depth, and we need to know the planted depth. So a series of non-destructive tests are carried out, and then we take the measurements with regards to bracket projection, bracket diameter, and the bracket rise. And then if you look at the bottom, you've got a diagram of the column. We're measuring from ground level to the bottom of the door, top of the door, and to the shoulder and the top of the shoulder. So a lot of extensive work goes into collating information from site. You then need to provide us information with regards to the attachment, obviously the number of attachments, the weight of the attachments. This one is a hanging basket, so we need to know the weight of it when it's watered as well, and your desired mounting heights too. So like I said, this information is collated, it's combined, it goes through the process of the design, and then we get an outcome in a report. This is the summary sheet from the report. The report's extensive. It carries a lot of commentary at the front end, and then the calculations are shown in the back end. But really, you want to know whether you have an approved attachment or not. On the left-hand side, you'll have the information of the unit number and the location, the street name. And then we work our way across. If I just bring the icon in here, you'll have the column height. You'll have the grade of steel, if we can identify that. There you have the base diameter, you'll have the shaft diameter, you'll have the tube base and the tube shaft measurements as well. And then you'll have a series of those measurements that we've already taken from ground level. So all of this information is collated, it's all then put through the design, and then at the end it'll kick out a pass or a fail. And then with a commentary on the right hand side, which will recommend the mounting height of the attachment. If you can see here, those that have failed, in this case, have failed because there are losses that we've identified through the structural test. So these are bearing root section losses. They've actually got some road traffic damage as well. So some of these are dented, and generally we find that columns that have got compromised base compartments or shafts, creases, where they've been hit, where they're not aligned correctly, will fail the design process as well. So it's really useful if you are looking to attach infrastructure to a lighting column, to survey them, make sure they're actually visually in acceptable condition. Then you can go ahead and do a non-destructive test and then do the calculations via all of the measurements that we collect. Why are we doing this? We're doing this for an important health and safety reason, because we know that the attachment needs to be determined, and whoever instigates that erection of the basket, of the lighting attachment, the decoration, is taking the main responsibility for health and safety. So they must ensure that the correct application process is followed, and that all attachments are correctly supported where applicable. The reason they do that now is governed under CDM. These regulations place the responsibility and the legal duty on the person who organises the project. So they're responsible for the project, which means they're responsible for appointing a suitably qualified contractor, someone that is registered to the appropriate trade body, be it HERS or the National Highway Sector Scheme. And as a competent contractor, you would then carry all the necessary qualifications and insurances as well. So other considerations, this is at local authority level. They will, by way of a license, use a section 178 from the Highways Act of 1980. And they'll also take guidance from the ILP PLG 06, installation and maintenance of seasonal decoration. So two important documents that they'll use, which will sometimes determine the requirements that they will deem necessary from site. That license will require the applicant to have the relevant items covered, and those items will be: have you appointed the correct contractor? Has he got the relevant qualifications? Has the applicant got the necessary insurances as well? And only once that's been determined and that license has been approved can that attachment be installed. So just summing up and just finishing, we're kind of getting to 20 minutes. If in doubt, cast it out. It's a famous saying, isn't it? If in doubt, design it out, really is applicable to this. Because you never know. You can have a column that could be substantial in appearance. It might be a column that you haven't had problems with over a period of time, but that fatigue can set in due to weather conditions, and parts of the column can deteriorate and may not be subjected to non-destructive testing. And where you've got a configuration of multiple lanterns or floodlights or anything excessive, then the potential for failure is there. So if in doubt, remember to design it out. And just finishing off, really, we've just got something to just advise you, really, is that a new service that we're launching in the new financial year is an application. It's called an ACCA, and that's going to allow you to use a site app, and for you to go and do these measurements yourself, for you to go back and use a data sheet that we've shown you, for you to record the column heights, for you to record the wall thickness of the base and the shaft, for you to design for yourself the column attachment and obtain an approval through an app. So this will be available to you. What it will do will allow you to maybe turn around approvals quicker, because normally your process will go through an audit, it will go through a programming stage, it will get assigned to an inspector. but it might be that the column that you're looking to design for is 10 years old. It might not require a non-destructive test, so it might be suitable just for a design. Well, you'll be in a position to go and do that there and then, and you'll have approval there and then. So we look forward to launching the asset attachment check application in the new financial year, and looking forward to helping you with that. So that concludes the webinar. I hope there's some information there for you. We'll upload this webinar to the website as well, and that will allow you to go over some important points within the webinar and save those and refer to them. But for now, like I said, we'll open up for questions. Happy to hear those and hopefully answer them for you as well. So thank you.
Yeah, that's great. So I've got a question here from Jim, who says, is there anything we can do ourselves to identify a column that would fail an EN40 design rather than sending you out to site first?
Yeah, I mean, that's a really good question, actually. And it's a bit of a frustration for us sometimes when we go to complete a non-destructive test and already there's obvious damage to the column, so the base compartment's dented or the column's leaning, because those really will get filtered out at the start of the process and they won't be suitable for the attachment. You'd need to replace the column. So just a simple site survey to determine visually clean columns, and also potentially columns that don't support existing attachments. You've then got the very best chance of getting your attachment approved then.
Okay, great. I've got a question here from Phil, who says, is there a standard column that will always pass an EN40 design, i.e. like a coastal spec column?
Yeah, I think that would always be desirable to have a column with the highest grade steel and a column that has potentially got the thickest wall section to the base and the shaft. So yeah, I think you've got a much better chance using those columns. As I said earlier on in the webinar, the modern column, the 3mm column that is very close to the limit when it leaves the factory, will always have issues when it's put forward for a design. So upgrade your columns if you can when you install them.
Okay, super. We've got a question here from Fiona. If we're putting the same festive lights on the same column every year, do we need to do a test every year?
I think it depends very much on the age of the column. So I think if the columns are within 12 years old, then I would say a visual inspection will suffice. It'll just need the design the once. If you're going back to site, you're checking to see if there's any additional attachments have gone on that you don't know about. So that would potentially overload the column if that's the case. So you need to identify that. Visually, you need to check, has the column suffered any damage since the last test? And actually, while you're doing that, you may as well structurally test it. So my advice would be carry out the design in the first instance, and then annually pay a visit to that column and complete a test.
Super, right. And then just the last question at the moment, unless anyone else has got any more. A question here from Sue. Will you be carrying out the calculations yourselves rather than using a consultant, which tends to delay results?
Yes, we will, Sue. So right at the end of the presentation, the application that we've developed, which we're launching in the new financial year, we'll also be using in conjunction with the structural testing, which basically means that we can input the test results and the design data and turn the report around quickly. So yes, looking to condense the time from issuing an order to issuing a report.
Great. Thanks, James. There are no further questions at this time. So really, if no one's got anything else to say, thank you all for attending. It's been great to have so many of you join us today. We don't have any immediate plans to do another webinar, but we will have a chat if anyone's got any more suggestions. I know this particular topic was picked by one of our clients, so hopefully that's help. And we'll be happy to do another one. So if you've got any topics that you'd like us to cover, then please let us know. Otherwise, thanks again for joining us. Stay safe, and we hope to see you all again soon.
We'll see you all soon. Yeah, that's the plan.